Good morning. This is Rajasree, working as assistant professor from Department of EEE, Amit University. Uh, I'm going to discuss about the fundamentals of electric circuit. This is a basic topic or basic subject which is used for the electrical engineers and also for EC members also. The first thing I'm going to discuss here is circuit analysis definition, and then a classification of circuit elements, short and open circuits, and then Ohm's law, Kirchhoff's law, then source transformation, and then finally power and power factor. So first, what is electrical analysis? Nothing but, for example, if you are taking electrical circuit which consists of sources like current or voltage source, and also like circuit elements like resistance, inductance and capacitance. So these are the things we are having. We are going to analyze and study about these circuit elements and sources, nothing but the electrical analysis or circuit analysis. And then we'll move on to the circuit elements. Since we are having two classification of elements, one is a passive element and then the active element. The passive element is nothing but it is used to absorb the heat, and the example will be like resistance, inductance and capacitance, nothing but the circuit elements which are using in the circuit networks. And then the active element, nothing but the sources, voltage source and then current source and all. And then next we move on to the short and open circuit. For example, if you are considering the source and the circuit elements in the network, if you are going to short circuit the voltage source, then the current will be flowing across the circuit and the voltage will be becoming zero for the short circuit. Whereas in open circuit, we are having the source and the circuit elements. If we are going to open circuit the sources, then current will be zero and voltage will be some minimum value will be there. Basic one is the Ohm's law. It is nothing but the voltage applied to the circuit is directly proportional to the resistance and the current flowing through the circuit for constant temperature. The main thing is V is directly proportional to current and resistance. At what condition means at constant temperature condition. It can also be defined as I is proportional to V by R, and then R is equal to V by I. Here the R will be considered as the constant value. Now next we'll move on to the Kirchhoff's law. We are having two different types of Kirchhoff's law. One is Kirchhoff's current law and then Kirchhoff's voltage law. So Kirchhoff's current law is nothing but, for example, if you consider a junction or a node, the sum of incoming current will be equal to the outgoing current. This is the Kirchhoff's law. Kirchhoff's voltage law is nothing but, for example, if you are considering a circuit with a voltage source and circuit elements, the sum of the algebraic sum of voltage and the electromotive force will be equal to zero in Kirchhoff's current voltage law. And then we'll move on to the source transformation. It is nothing but, for example, if you're having a voltage source in series with a resistance, and that voltage source will be converted to current source, in which we'll be having, instead of voltage source, we'll be having a current source in which the resistance will be in parallel. So in voltage source we'll be having a resistance in series, whereas in current source we'll be having the resistance in parallel, and then vice versa. For current to voltage also, for current transformation we'll be having resistance in parallel, whereas for voltage we'll be having resistance in series. Then we'll move on to the power and power factor. Power is nothing but the work done. And then for electrical based, the power formula is nothing but P is equal to VA, nothing but the product of voltage and current. In between the voltage and current, we will be having an angle, and that angle will be mentioned as cos phi. So for single phase, it will be mentioned as P is equal to VI cos phi, whereas for three phase, it will be considered as P is equal to 3 VI cos phi. And we have three different types of power. First one is real power, then second one is reactive power, and third one is apparent power. For real power is nothing but a normal power. The formula is P is equal to VI cos phi. Whereas for reactive power, the angle will be modified as Q is equal to VI sin phi. And then the apparent power will not be having any angle. So PS is equal to V into 1. Similarly, the power factor. Power factor is nothing but the ratio of resistance and impedance, or we can also define as the real power by an apparent power. And then finally, we'll be having three different types of power factor. One is the unity power factor, the second one is lagging power factor, and then third one is leading power factor. In unity power factor, the voltage will be equal to the current, which means the voltage and angle, voltage and current will be in same phase. And for lagging power factor, the current will lag the voltage by 90 degree, and for leading power factor, the current will lead the voltage by 90 degree. Thank you.